I'm Nova.
I'm Alloy, and this is AgentStack Daily.
NVIDIA's Nemotron 3.5 Lightning has landed on OpenRouter with 3 billion active parameters drawn from a 30 billion parameter mixture of experts model. Only part of the network handles each token, targeting high throughput without activating the whole thing every time. It also accepts 262,144 tokens at once, so long agent histories and large document collections get considerably more room.
And specialized models are turning into products people can reach where they already work. Security teams can access OpenAI's Daybreak models through Amazon Bedrock. Microsoft's new Copilot model can interpret screenshots beside code. Video creators can generate short, multi-shot clips with open weights on NVIDIA hardware. Okay, that's a real shift. These models aren't just demos looking for a destination.
Today, you'll hear about ads entering ChatGPT, Zapier and Virgin Atlantic using ChatGPT work, Mistral assembling a European sovereign AI stack, and Google moving a medical research system into live video consultations.
Plus GitHub's September model cutoff, 3 busy open-source agent projects, Minimax H3's audiovisual pipeline, and CareAccess attempt to make radiology models more clinically useful rather than merely more fluent.
NVIDIA has listed Nemotron 3.5 Lightning on OpenRouter as an open model aimed at high-throughput agent work and specialized tasks. It uses a mixture of experts design. The full network contains 30 billion parameters, but only 3 billion are active for a given token. In ordinary language, each piece of a prompt travels through a smaller selection of specialized components instead of activating the whole network every time. That can reduce computing cost per response while retaining a broader pool of learned capabilities. OpenRouter lists a 262,144 token context window, enough capacity for substantial repositories, long customer histories, collections of reports, or extended agent sessions. NVIDIA isn't pitching Lightning as the largest possible reasoning model. It's pitching a small active footprint for workloads where volume, latency, and cost matter. Repeated classification, retrieval, summarization, tool selection, and the many intermediate steps an agent may perform before producing a final answer.
Which is more useful than another huge context means huge intelligence claim. An agent may need to summarize support records, sort documents, preserve instructions, or call tools repeatedly without paying premium model rates at every step. Lightning's 3 billion active, 30 billion total split is designed for that territory. But I don't buy the specifications as proof that it'll handle every long session well. A model can accept 262,000 tokens and still overlook a qualification deep in the input, and expert routing helps only when it keeps choosing the right components as the task changes. OpenRouter makes the model easy to reach through an API, while the open model framing leaves room for other deployment choices. The decisive evidence will come from actual agent work involving retrieval, changing instructions, long histories, and repeated tool use. If Lightning holds up there, it could become the inexpensive worker handling routine steps while larger models take the hardest decisions. That division of labor is where mixture of experts efficiency gets genuinely interesting. NVIDIA is calling attention to local AI throughout August, but did something specific ship here, or is this ecosystem marketing wearing a very enthusiastic jacket?
It's mostly a roundup and a statement of direction. NVIDIA's August 11th post points to its latest open models, including work around Nemotron, plus software, applications, partners, and communities building local agents. The source itself doesn't announce a new model version, API, or tool with a changelog. Instead, it groups the ecosystem under one banner and argues that capable AI can increasingly run on hardware controlled by the user rather than exclusively through a hosted service. That can mean enthusiasts building private assistants, developers modifying open models, or organizations keeping sensitive data closer to their own machines. The concrete releases live in linked community projects and later posts, not in this overview. So, no, there isn't a mystery product hidden behind the confetti.
Fair, and that distinction matters. Local agents becoming practical would be exciting. The evidence has to come from the models, runtimes, and applications underneath the campaign. Nemotron Lightning gives the message one concrete anchor because it combines open distribution with a small active footprint. The video model we'll get to later provides another, though that's a very different workload. NVIDIA benefits whenever more AI runs on NVIDIA hardware, so it's hardly a neutral observer. Still, a coordinated push can make scattered work easier to discover. The useful development is the growing number of projects that keep weights, data, and execution closer to people's machines. That can support privacy, customization, offline operation, and independence from a single hosted interface, although none of those benefits arrives automatically. August's roundup shows where NVIDIA wants the market to move. The downstream software will show whether local agents become easier to operate or remain a collection of impressive parts.
OpenAI's Daybreak cybersecurity models are now available through Amazon Bedrock. AWS customers can reach OpenAI's security-focused capabilities inside the managed model catalog they may already use for other AI workloads. A security organization standardized on Bedrock won't need a completely separate model platform simply to access Daybreak. The announcement also establishes Bedrock as a distribution channel for OpenAI's cybersecurity work alongside OpenAI's own services.
That's a meaningful commercial move. Bedrock already puts competing providers inside one managed environment, and OpenAI is placing specialized security capability on that shelf. The audience is an enterprise security team bringing a purpose-built model into an existing AWS estate. Consolidated access matters when cloud agreements, identity systems, procurement, and internal controls already run through one provider.
Availability doesn't establish adoption. The announcement supplies no usage numbers, detailed pricing, or measured customer outcomes. It also shouldn't be mistaken for unrestricted offensive access. Daybreak Red is framed around authorized research and testing. A major cloud catalog changes distribution. It doesn't prove effectiveness in a specific security environment. Bedrock may simplify identity, logging, and procurement around model access, but each customer still has to evaluate how sensitive findings move through its own workflow and where human review belongs.
Amazon gets differentiated security models, while OpenAI gets proximity to enterprises that may not want another standalone platform. The advantage may be organizational as well as technical. Specialized capability enters through familiar infrastructure. Real deployments now have to show what work teams assign to Daybreak and whether it shortens investigations without creating new blind spots. A catalog listing is the start of distribution, not evidence that a security team has integrated the model into incident response or vulnerability triage.
OpenAI released GPT 5.6 Cyber on August 10 through Daybreak Red, a controlled access program for authorized vulnerability research, exploit validation, and security testing. It isn't a general model in the ordinary ChatGPT picker. OpenAI has separated it by audience and purpose because the work can help defenders but also carries obvious misuse concerns.
I'm glad the boundary appears in the product description rather than after the capability claim. Better vulnerability reasoning can shorten defensive work, but the same skill can assist an attacker. Daybreak Red gives OpenAI a defined audience and explicit purposes. The controlled route acknowledges that useful security work sometimes requires discussing behavior ordinary safety systems avoid.
The announcement doesn't include independent benchmarks, customer outcomes, or enough detail to compare the model with established security tools. Exploit validation can range from checking a proof of concept to examining behavior in isolation. The verified scope is authorized activity, and a specialized language model doesn't replace scanners, debuggers, sandboxes, or human judgment. Those tools produce observable evidence. The model may help connect that evidence, propose hypotheses, or explain code paths, but its conclusions still need reproduction inside controlled systems.
Still, the release changes how a frontier provider packages risky capability, a specialized model behind a gated route. The question is whether legitimate researchers find it materially better across code, system behavior, and incomplete evidence. Tight controls can reduce misuse but also exclude smaller researchers. Daybreak Red has to support serious defensive work without becoming either a loophole or a velvet rope. Its application rules, review speed, and treatment of independent researchers will matter nearly as much as the model's raw capability.
OpenAI has begun testing ads inside ChatGPT, saying sponsored content can help preserve free access. The company makes 4 commitments: ads will be clearly labeled, paid placement won't influence generated answers, privacy protections will apply, and users will have controls over their ad experience. The test concerns consumer ChatGPT rather than the API used by third-party applications. So people using ChatGPT may see the immediate change. Developers aren't suddenly receiving advertisements inside API responses. OpenAI hasn't disclosed the complete formats, placement rules, or rollout schedule, which leaves the most visible part of the change, the actual experience, unanswered. It also leaves open whether ads follow a conversation's current topic, broader account signals, or a more limited contextual system.
And, yes, I'm skeptical until we see that placement. Answer independence is easy to promise and harder to make legible. A search page can put an ad in a marked box. A conversational system produces fluid answers that people may treat as personal advice. If sponsored material appears near a product recommendation, the line between "the model suggested this" and "someone paid to be here" has to remain unmistakable. Privacy deserves equal scrutiny because conversations can reveal health concerns, financial plans, travel intentions, and purchasing interest before someone has decided to buy anything. Ads may subsidize free access, which is a real benefit. They also alter the trust relationship around a product whose value depends on people believing an answer was generated for them rather than for an advertiser. Clear labels are the starting condition, not the finished proof. Controls will need to be understandable before a sensitive conversation begins, not buried after targeting has already happened. Zapier is already synonymous with connecting software, so what did its marketing team actually give ChatGPT work?
OpenAI's August 10th case study names 3 jobs: finding and reducing drop-offs in the lead funnel, creating campaign assets, and automating reporting. That places the tool across analysis, content production, and recurring measurement rather than in one copywriting role. A lead funnel tracks how prospective customers move from initial interest toward purchase, and a drop-off is the point where many of them leave. ChatGPT work can help a team inspect that journey, turn findings into campaign material, and organize the reporting that follows. OpenAI is presenting a customer example, not announcing a new capability. The case study gives no conversion lift, hours saved, campaign counts, or detailed integration design. It tells us how Zapier grouped the work, but not how large the gains were. That makes it evidence of adoption inside a recognizable automation company, not proof of a quantified result.
And the grouping is still useful. Marketing teams often buy separate AI products for funnel analysis, creative generation, and reports, then waste time moving context among them. Zapier's example suggests ChatGPT work is being sold as a shared environment where related tasks remain connected. A funnel problem can influence campaign material, and campaign activity can feed reporting without rebuilding all the context. Given Zapier's automation business, its internal adoption carries more weight than a generic testimonial, but I'd want numbers before calling it a success. Did fewer leads disappear? Did campaigns launch faster? Did automated reports reduce work, or did people spend that time correcting them? The concrete news is narrower. Zapier's marketing team has moved recurring work across 3 linked stages into ChatGPT work. That's meaningful adoption, just not a measured victory lap.
Virgin Atlantic is putting ChatGPT work in front of teams responsible for the customer journey. The airline says employees use it for research, product planning, and decisions by connecting information across a traveler's experience. Product, marketing, and service staff can contribute to the same picture instead of rebuilding it from departmental slices.
That's more interesting than another passenger-facing travel bot. Virgin Atlantic is starting behind the scenes, where teams decide what the experience should become. A shared workspace could connect research, service feedback, and plans before a passenger sees any AI-generated output. But the company hasn't published time saved or decisions improved. So what's the organizational question underneath the pitch?
whether teams can access and interpret the same information. Service records, marketing data, research, and plans may carry different permissions and definitions. ChatGPT work can provide a common surface, but it can't repair fragmented data or unclear ownership. Connecting documents may expose disagreement rather than resolve it. Software remains unable to heal an org chart through inspirational proximity. An airline also handles unusually sensitive travel and identity data, so the useful workspace has to respect access boundaries while still joining enough context to help.
This builds on Zapier's use. Both position ChatGPT work across linked activities, not as an isolated prompt box. Zapier joins funnel analysis, campaigns, and reporting. Virgin Atlantic joins research, planning, and decisions. Neither provides hard metrics. Whether the result improves decisions still depends on access, data quality, and human judgment. The credible next evidence would be shorter research cycles, fewer duplicated handoffs, and examples where connected context changed a concrete customer decision.
Mistral is combining in-region inference, open weight models, and new European computing capacity intended for long-term use. It presents that bundle as a sovereign AI stack. In-region inference keeps requests within the relevant geography, while open weights let organizations inspect or host models subject to licensing and technical requirements.
Sovereign can sound like a flag wrapped around a data center, but the concerns are concrete. Governments and regulated companies care where information is processed, which laws govern it, who controls infrastructure, and whether they can continue operating if a foreign provider changes terms. Mistral says it can address models, hosting, and capacity together.
I don't buy the complete sovereignty pitch until Mistral names jurisdictions, infrastructure details, and customer commitments. Europe isn't one interchangeable legal zone. Data location requirements vary, and self-hosting creates substantial operating costs. The announcement provides a roadmap, not proof that every organization can immediately move production workloads into an ideal local setup. Buyers will also need clarity on model updates, service availability, incident response, and what happens when a workload crosses borders during failover.
Still, Mistral is competing on control rather than only scores. A public agency may value inspectable weights and regional infrastructure even if another model leads a benchmark. Specific regions, available capacity, contracts, and signed deployments will determine whether the bundle changes procurement. It connects with NVIDIA's local push at a different scale, control on a workstation versus control across regional infrastructure. If Mistral can join those layers under clear operational commitments, sovereignty becomes a deployment property rather than a marketing label.
GitHub Enterprise Server 3.22 is available as a release candidate, the preview stage before general availability for GitHub's self-hosted platform. The announcement highlights one specific capability: administrators can configure Copilot CLI inside the deployment. That gives organizations running GitHub Enterprise Server a management surface for the coding tool within their environment. The source mentions broader platform capabilities but doesn't enumerate them in the available summary, so there's no basis here for claiming a larger collection of behavior or integration changes. A release candidate also gives administrators time to test upgrades, policies, and integrations before treating the branch as production-ready.
That preview label matters because GitHub Enterprise Server serves companies keeping source hosting on premises or in a private cloud. Those environments often impose tighter administrative controls than the public service. Copilot CLI configuration appearing at the administrator level reflects that reality. An enterprise wants centrally managed settings around access and provisioning rather than every developer improvising independently. But, no, the headline doesn't establish exact permission behavior, security changes, or compatibility details. GitHub's release notes have to carry anything beyond that named capability. The solid news is a release candidate for the self-hosted platform and an administrator configuration surface for Copilot CLI, not a blank check for us to invent the rest. Teams evaluating it should compare the candidate against their existing authentication and network boundaries before general availability. September 10th is the hard date. GitHub will retire MAI Code 1 Flash from every GitHub Copilot experience and names MAI Code 1.1 Flash as the successor. Is anything else hiding in the notice?
No. GitHub's August 11th post supplies the retirement date, outgoing model, and suggested replacement. It gives no benchmark figures, pricing, context length, or detailed transition behavior, so the calendar is the news. Any Copilot setup explicitly selecting the older model will face a changed availability boundary at the cutoff. Workflows using automatic routing may behave differently, but the notice doesn't explain how. And although the successor has a separate announcement with native vision, this deprecation notice doesn't establish performance equivalence. GitHub is saying which model replaces the old option, not proving they behave identically. Teams with internal guidance built around the outgoing model now have a finite window to revisit that guidance,
which exposes the tension between hosted convenience and model churn. Copilot can add models quickly, but a named dependency can disappear on a fixed schedule. GitHub has at least supplied a date and direct successor rather than silently removing the choice. The uncomfortable part is that 1 month's model selection becomes another month's maintenance event. September 10th ends the old Flash model across Copilot. That can affect saved preferences, documentation, internal comparisons, and any work built around an explicitly named option. A meaningful quality comparison has to come from the successor's disclosed capabilities and observed use, not assumptions attached to a decimal. Conveniently, the successor does have one very clear new capability. The notice is useful precisely because it turns vague churn into a deadline organizations can plan around.
Microsoft's MAI Code 1.1 Flash is rolling out inside GitHub Copilot with native vision support. The coding model can interpret images beside text and code. A developer can provide an error screenshot, interface mockup, or hand-drawn diagram without translating every visual detail into prose. Microsoft also claims improved coding quality, but the announcement doesn't provide complete benchmark details.
Okay, that's genuinely useful. Software work often begins with visual evidence, a broken layout, browser error, design export, or whiteboard sketch. Keeping the image and code in one conversation avoids a lossy manual description. It also gives context for GitHub directing users away from the retiring model, though the deprecation notice doesn't promise identical behavior.
I'd still separate inspecting an image from fixing software. A screenshot may reveal an overlap without exposing the style rule, browser condition, or state transition causing it. A mockup can guide a component without specifying accessibility or every responsive breakpoint. Vision supplies evidence. It doesn't turn pixels into complete requirements or prove the broader quality claim. The strongest workflow would connect the image to repository context, runtime output, and a reproducible test rather than treating the screenshot as the whole bug report.
But the model can now discuss the actual screen beside relevant code. A visual bug report can begin with what happened, and a diagram can clarify relationships awkward to describe line by line. Rollout may be staged. Native image understanding is the verified edition. Broader quality improvements remain Microsoft's claim. This is more than a replacement name, it's a new input mode inside Copilot. It could be especially useful for interface regressions, generated charts, architecture sketches, and logs captured as images, as long as users still verify the resulting code change. Amy began as a text medical dialogue system. Google's research now extends it into real-time clinical video conversations, where it processes a person's face, voice, timing, and tone while responding live. That makes the interaction richer and more demanding. Pauses, expressions, hesitation, and latency can all shape a consultation. Google describes a first-of-its-kind study, but it took place in simulated settings rather than with real patients.
That boundary is central. A controlled consultation can show whether an AI sustains conversation and responds to audiovisual cues. It can't reproduce care involving real illness, incomplete records, emergencies, consent, and accountability. Video may help people who struggle to type detailed histories, but it creates more ways to misread someone and more sensitive information to protect. A frown could reflect pain, confusion, bad lighting, or nothing clinically relevant. A change in tone may matter, or it may be background noise and network delay. Low latency improves conversation, yet confident speed isn't clinical accuracy. The system also has to maintain context while audio and video arrive continuously, a different technical burden from answering a completed text prompt.
Exactly. People shouldn't collapse held a realistic consultation into ready-to-treat patients. Google has shown Amy handling richer simulated exchanges. It hasn't established autonomous clinical authority or a particular real-world error rate. Diverse participants, professional comparison, privacy protections, perspective evaluation, and responsibility for mistakes remain open. The work is exciting because live clinical conversation is difficult, and worrying for the same reason. A video system sees a face and hears distress, which can make misplaced confidence more persuasive. This is a research milestone, not a digital doctor entering routine care. Any practical role would need clear escalation to clinicians when the signal is ambiguous or risk is high.
LTX 2.5 brings an open-weights video model to NVIDIA accelerated local workflows. Its published capabilities include clips up to 6.8 seconds, native multi-shot generation, and Comfy UI support. Comfy UI connects generation and media processing steps into reusable visual workflows. Multi-shot generation lets the model produce a sequence with more than one shot instead of treating every clip as isolated.
That's compelling because video creation often means bouncing among hosted generators, editors, and processing tools. Open-weights offer more control over where generation runs, while Comfy UI places the model in a modular media ecosystem. A 6.8-second ceiling doesn't produce a film, but multiple shots can help create storyboards, transitions, advertisements, and pre-visualization where continuity matters.
The source doesn't establish every hardware requirement, license condition, or production quality claim. NVIDIA acceleration isn't the same as running well on every card, and local video may demand substantial memory. Open-weights improve access and inspectability. They don't guarantee cheap operation, fast output, or consistent characters. Actual throughput will depend on resolution, precision, memory, and the rest of the workflow around generation.
NVIDIA's local AI campaign now has something tangible behind it. A creator can preserve editable Comfy UI nodes and generate short multi-shot material without centering a hosted service. Duration, hardware demands, and continuity remain limits. Nemotron Lightning targets repeated agent work, LTX 2.5 targets creative production. Together they explain why NVIDIA is pushing an ecosystem rather than one heroic model. The editable graph matters because generation becomes one reproducible stage among prompts, reference images, upscaling, color work, and export instead of a disposable web interaction.
CareX is a radiology research approach meant to move vision language models beyond plausible reports. It combines chest X-rays and clinical language with extra training signals, rewards aligned to desired reasoning, calibrated predictions, and measurement tools. Calibration means confidence should correspond more closely to how often the model is correct. That matters because medically fluent language can still be dangerously wrong.
I like that the research aims at usefulness rather than eloquence. Radiology involves findings, measurements, comparisons, and uncertainty. A model that writes polished prose but invents a measurement is worse than one admitting it can't tell. CareX uses guidance from related clinical tasks and measurement tools when a question needs a quantitative answer. That pushes it toward evidence instead of language that merely sounds clinical.
Clinically useful is the goal, not a deployment status. Nothing supports treating CareX as ready for unsupervised diagnosis. Chest X-rays vary with equipment, positioning, populations, and settings, so calibration can weaken elsewhere. Tool use adds another dependency. The model must choose the right tool, apply it to the correct region, and interpret the result. A precise measurement can still be attached to the wrong structure. External validation matters because a confidence score learned from one hospital's images may not transfer cleanly to another hospital's devices and patient mix.
It pairs neatly with Amy. Amy adds real-time human signals, CareX tries to make image reasoning measurable and uncertainty aware. Both recognize that medical AI needs more than fluent text. Neither removes clinicians, perspective evaluation, or accountability. The decisive question is whether gains persist across diverse conditions without increasing automation bias. Better tools should make uncertainty easier to see, not merely make reports sound more certain. A useful system would help a radiologist inspect the evidence behind a finding and recognize when the model's confidence is poorly supported.
3 repositories are drawing attention. HKUDS's Nanobot is a self-hosted Python agent framework with a web interface, tools, memory, automation, multi-agent workflows, chat apps, and model context protocol support. Nanobot has about 46,884 stars, released 0.3 in July, and was updated August 12. Its appeal is broad functionality in a lightweight package.
Codebase Memory MCP and FastMCP approach the tool layer from opposite directions. Codebase Memory builds a persistent code knowledge graph and has roughly 38,653 stars, up 7,799 in 30 days. Its maintainers claim 158 language support, sub-millisecond queries, and 99% fewer tokens. Those claims need independent reproduction. FastMCP has about 27,187 stars and grew by just over 1,000 in 30 days. One supplies code understanding, the other helps Python developers create MCP servers and clients.
Together they resemble an agent environment, durable repository context, and a Python tool interface. They can serve MCP-compatible systems, including the terminal-based AI coding agent Claude Code and the terminal-based coding agent Codex. A shared protocol doesn't guarantee interoperability, but open-source work is converging on reusable tool connections. Nanobot's star count shows appetite for self-hosted agents, while Codebase Memories gain points to demand for persistent repository understanding.
Nemotron 3.5 Lightning is the selected model, an open NVIDIA mixture of experts system with 3 billion active parameters from 30 billion total and a 262,144 token context window through OpenRouter. NVIDIA positions it for high-throughput agents and specialized jobs. The notable combination is a small active footprint, long context, and straightforward hosted access, not proof that it outranks heavier reasoning models.
Minimax H3 is trending as an open media generation model with 3,653 likes and more than 59,000 downloads. Its tasks include text-to-video, image-to-video, video-to-video, and workflows producing video and audio from text, images, or footage. Diffusers and Saphir support place it near established open model pipelines rather than behind one hosted interface.
Okay, that breadth is exciting. H3 can transform several input types into audiovisual output instead of serving one narrow path. Local operation still depends on license, runtime support, and hardware requirements. The downloads show interest, not guaranteed production quality. Alongside LTX 2.5, it shows open creative AI expanding into adaptable video and audio workflows.
Liquidari's LFM 2.5 2.6b GGUF, trending on Hugging Face, has passed 111,000 downloads as a compact model for common local runtimes. Pair it with Mistral's in-region inference, open models, and new European infrastructure for sovereign AI. Liquid puts control near the device, while Mistral tries to provide it at regional scale.
GitHub's MAI Code 1 Flash deprecation is the counterpoint to both. The model leaves every Copilot experience on September 10th, with MAI Code 1.1 Flash named as its successor. Liquid's compact local package and Mistral's regional stack both emphasize control over where models run. GitHub shows the trade-off at the hosted end, convenient access, but availability follows the provider's calendar.
For the source details behind the research, releases, models, and projects, look at the show notes at tobyonfitnesstech.com.
Thanks for listening. We'll be back soon.